Okay, finding all zeros. First and foremost, I apologize for making so many mistakes. I really don't mean to. I think it's just part of being human. So maybe learn from that. Learn that it's okay to make mistakes. I know there's a mistake in the last video, so sorry about that. Anyways, let's keep going. So we need to find all zeros and then write our answers in simplest form. So we have x to the fourth minus 9x squared plus 18. Now, if this was x squared minus 9x plus 18, this would be easy to factor, right? Well, it still is easy to factor. We just have doubled our x squared and we've doubled our x, okay? Because this right here would factor to x minus 3, x minus 6. So my x to the fourth minus 9x squared plus 18 will factor to x squared minus 3 because we're just going to take half of that x to the fourth and x squared minus 6. Okay, and then we're finding the zeros, possibly maybe. So I'm just going to set each equal to 0. So I have x squared minus 3 equals 0, x squared minus 6 equals 0. So I can get x squared equals 3, square root both sides, which means x equals the positive or negative square root of 3. And you have to put plus or minus there. We're going to do the same with the 6, add it over, square root both sides, and you get plus or minus square root of 6. And those are our answers. Okay? You can do example B. That's the answers you should get. Just make sure you break down that square root of 8 to 2 square roots of 2. Okay? Then example C, we're going to factor this by grouping. So I'm going to group the first two, group the second two. So I have 2x cubed plus 5x squared and then negative 24x minus 60. I can take out an x squared from that first one and I get 2x plus 5. I can take out a negative 12 from that second one and I get 2x plus 5. So I get x squared minus 12 and 2x plus 5. Now I'm going to set those both equal to 0. Possibly, maybe. Add the 12 over. You get square root both sides. I get plus or minus square root of 12, which the square root of 12 breaks down to 2 square roots of 3. And you should know how to do that, so I'm not going to go through all those steps. On this next one, I'm going to subtract the 5 over, divide by 2. So those are my two answers there. Okay, you can do example D. You should get 2 square roots of 3 over 3 and 5. I might go over this one in class just because I need to show you guys that you can't have a square root in the denominator, so you have to get rid of that square root. I think you guys can figure it out. I have all of the confidence in you, so I want you to try it and see if you can figure that one out. Okay? Let's do this one. So math tip, always try factoring before you use the rational roots theorem. Okay? So here, first it asks us to list the rational roots, and I forgot. So remember, it's P over Q. My P here is 1. My Q is 36. Oh, whoops. Mistake. Sorry, guys. My P is 36. My Q is 1. So the possible zeros, zeros, that's going to be plus or minus 1, and plus or minus 36, plus or minus 2 and 18, 3 and 12, I'm running out of room because I write too big, 4 and 9, plus or minus, and then also 6. Okay, so make sure you write down the possible zeros as well. Then we're just going to factor this by grouping it because it will work if we group it. You could use the rational roots theorem. It will absolutely work. This also works, though. So then I can take out the x squared, and I get x minus 2. Take out the negative 18, and I get x minus 2. So I get x squared minus 18 and x minus 2. So x squared minus 18, x minus 2 equals 0. Add that 18 over, square root both sides. Break down that square root, it's 3 square roots of 2. And this one is x equals 2. Okay, let's look at F. This one we can't factor, so we have to use the rational roots theorem. So my a sub 0 equals negative 15, my a sub n equals 1, which means p equals negative 15, q equals 1. So my possible zeros are plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. If I plug in 1, I get negative 48. So that one's not going to work. Plug in negative 1, I get 8. Also doesn't work. Plug in 3, I get negative 120. That doesn't work. And I'm plugging these into this equation right there. Okay. Plug in negative 3, and I get 0. Yay. That was super enthusiastic. So negative 3 works, which means that negative 3 is a 0, and x plus 3 is a factor because you have to switch that sign back. And let's use synthetic division here to solve the rest of this. So I'm going to bring down that 1. 1 times negative 3 is negative 3. Negative 8 times negative 3 is 24. Negative 5, positive 15, and 0. So I end up with x squared minus 8x minus 15. Now, there is nothing that will multiply to be negative 5 and add to be negative 8. So we have to use the dreaded quadratic formula. Yeah, yay, we love quadratic formula. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And you should have memorized that last year. If you didn't memorize it, I will put up a link for a very fun song that you can listen to over and over and over again until you do memorize it, because fun, yep. It's not super, super vital, but that is something good to know because it is used over and over and over again in math. Okay, anyways, so we're finding the zeros of x squared minus 8x minus 5. So a equals 1, b equals negative 8, c equals negative 5. So that's going to be negative 8 plus or minus the square root of negative 8 squared minus 4 times 1 times negative 5 all over 2 times 1. Which is negative 8 plus or minus the square root of 84. If you put all that inside, if you simplify that out, over 2. That 84 breaks down to 2 square roots of 21. Now 2 goes into 8 and 2 goes into 2. So that's going to be negative 4 plus or minus the square root of 21. So my answers here are negative 3 and negative 4 plus or minus the square root of 21. Okay, so this right here, I need you guys to recognize that this is 2 zeros there because you have negative 4 plus the square root of 21, and you also have negative 4 minus the square root of 21. So just recognize that there are 2 different zeros there, okay? You can do examples G and H. Let's do this one. So just as polynomial functions can have real zeros, they can also have complex zeros, which means they have i's in the solution, or they have imaginary numbers. Okay, so if we factor x to the 4th minus 4x squared minus 12, that can factor to x squared minus 6 and x squared plus 2. So I'm going to set x squared minus 6 equal to 0, x squared plus 2 equal to 0. Add that 6, square root both sides, and I get x equals plus or minus the square root of 6. For this one, I'm going to subtract the 2, square root both sides, and then I have to pull out that I, so that's plus or minus I square roots of 2. Cool? For this one right here, now if this was, let's go back. This is just the difference of squares here. So the square root of x to the 4th is x squared. The square root of 16 is 4. So that's going to factor to x squared minus 4, x squared plus 4. Now that x squared minus 4, we could have factored that further. So if you wanted to right here, we could factor this a little bit further to x minus 2 and x plus 2. And then x would equal 2 and negative 2. Okay, I'll show you that we're going to get the same exact thing even though I didn't factor further. So I'm going to add the 4 over, square root both sides, and I get plus or minus 2 because the square root of 4 is 2 and we have to add the plus or minus. So that's the same as what I just did. Okay, on this one I'm going to subtract the 4, square root both sides, and I get plus or minus 2, and that negative becomes an I. Okay, You can do J and L if you want to. Those are the answers there. It looks like you had to use the quadratic formula for L. Okay, also skip N, M, and F. They're similar to those other ones. Okay, or M and N. I don't know what I just said. Okay, so the fundamental theorem of algebra states that if a polynomial function of degree n, where n is greater than 1, has at least one zero in the complex number solution. That means any real number is a complex number, because you can always add 0i, and it makes it a complex number. Okay? If c is a complex zero of a polynomial function, then x minus c is a linear factor of that polynomial. Okay, that's just putting into words what we already have gone through and what you guys already know. So let's look at this one. So this one factors to x squared minus 25 and x squared plus 1. So we need to find the zeros and then find the complete factorization. So I'm going to first find my zeros, add that 25 over, square root both sides, and I get x equals plus or minus 5. Here I'm going to subtract that over, square root both sides, and I get plus or minus I. So this is going to be x equals negative 5, positive 5, negative I, and positive I. So that's x plus 5, x minus 5, x plus I, and x minus I. Okay, then we're done. We can have i's here. This is also kind of correct. I'll talk to you guys about this in class. But this right here is going to multiply out to be that. Okay? Let's look at this one. So we have 9x to the 4th minus 35x squared minus 4. Or plus 35, sorry. So first I'm going to use slip inside here. I'm going to multiply the 9 to the 4. And I get x to the 4th plus 35x squared minus 36. Well, that's going to be x squared plus 36 and x squared minus 1. Divide those by 9, and I get x squared plus 4 and 9x squared minus 1. And you could do the difference of squares there if you wanted to, or let's just find our zeros first. So x squared minus 4 equals 0. Subtract that 4 over, and this should have been a negative, sorry. Whoops. Negative 4. Square root both sides, and you get plus or minus 2i. This next one, I'm going to add the 1. Divide by 9, square root both sides, and you get plus or minus 1/3. So then this is going to be x plus 2i, x minus 2i, x plus 1/3, and x minus 1/3. And kind of like the slip inside thing, we just need to slide that 3 back. So that's going to be x plus 2i, x minus 2i, 3x plus 1, and 3x minus 1. Okay, let's save the rest. Remember to take the quiz. Thank you. You guys are super awesome. Bye.